So looking at this geometric series, we can see that the ratio, the common ratio are, let's see if this is a geometric series first of all. So 2 over 3, the second term over the first term is r, the third term over the second term is 4 over 3. So yeah, it's a geometric series because common ratio is 2 over 3 and a is 3. So the first question is, write down a formula for the sum Sn of the first n terms. So we know the formula for the sum is, since r is less than 1 in this case, we will have something like this: 1 minus r to the power n 1 minus r. If r was greater than 1, then the formula would go like this. That's the thing, so that the sum is a positive value. So yeah, so in this case it will be this one, which is, let's plug in the values here. So a is 3, 1 minus r is 1 over 2 over 3, and 1 over 1 minus 2 over 3 to the power n. So this one is a, if I do this division, it's 1/3 in the denominator and the 3 goes above, so it becomes something like this: 2 over 3 n, and then another bracket here, so I can give like that. So this is the Sn. So this is the first one. The second one says, explain why the geometric series has a finite sum. That means a limiting sum. So limiting sum means if the geometric series goes for infinity, up to infinity, the sum is a finite value. So the sum, there is a limiting sum. If I do like that, we can see it does have a limiting sum because r is, the magnitude of r is less than 1. It satisfies this condition, so it does have a limiting sum. So the limiting sum, as we know, is this one, because r to the power n becomes 0 when n reaches infinity. So if I plug in the values again, it will be 3 here, 1 minus 2 over 3, so it's 1/3 again, so this becomes 9. Okay, so now the last one says that find the smallest value of n for which this one, so this is the limiting sum and this is the sum up to n terms. So the subtraction is less than 0.01. So let's plug in the values. This one is 9 and this one is 9, and then 1 minus 2 over 3 to the power n, and then this is 0.1. So if I do this thing, this is becoming 9 2 over 3 n, and this is 0.1. So this is going away, this is like that. So what I can do is, since my unknown value is as a power, what the best way to solve these things is taking logarithm on both the sides. So I haven't made any logarithm video, but if I take this one, if I take logarithm of this one, then this is equals to ln of a. So the power is coming as a product. So that thing I will do here. If I take ln on both sides, this ln, which is the natural logarithm, so then it becomes, before that let's take the 9 on the other side, so it is becoming this one, so 2 over 3 and then n, and this is the division, this one becomes 1.11 into 10 to the power minus 3. Now if I take logarithm on both sides, so it becomes like that, 1 into 10 to the power minus 3. So this one is becoming something like that, ln 2 over 3, because the power is coming as a product. This is coming from the principle of logarithm. So, and this one is getting 6.81, something like that, and then this side ln 2 over 3 is something like minus 0.41 n and minus 6.1. So both side has negative, the negative is going away, and n is becoming less than 16 point, greater than less than 6%. So the minimum value of n will be the first whole number after this, which is 17. So n has to be 17 for this to be valid.